Carl is one light day from Earth. We can't see Earth from a light day away, so he's using a telescope with incredible magnification. What we see on the middle of the screen is what Carl sees. There are 20 space stations that rotate in precise synchronization with Earth that we will use as clocks. They are each spaced one light day apart. A station that is 20 light days away will see Earth 20 days in the past. Likewise, if a station is 1 light day away, it sees Earth 1 day in the past. You can see this displayed on the calendar clocks. The calendar clock on the right shows the apparent Earth date. Since the speed of light is finite, it diverges from the Earth's actual time depending on how far you are away. The one on the left shows the actual Earth date. When Carl sees February 4th through his telescope, which will actually be February 5th, he will launch at half the speed of light. Notice that the Earth and the space stations are rotating at a slower rate relative to Carl's inertial reference frame. Carl is traveling at half the speed of light. He will therefore pass a space station once every 2 days. It appears that the Earth and space stations are rotating exactly half the rate of Carl's space station. At half the speed of light, the special theory of relativity requires time to slow at a rate of 0.866 times the normal rate. Slowing at half the normal rate is a contradiction to the special theory of relativity. Each time Carl passes a station, everyone agrees on apparent and actual time. After all, they are in close proximity and couldn't possibly see a different day through their telescopes just because they're moving. We are going to stop at the 5 light day station. We will check to see if all the numbers work out or if there's something bizarre going on. Carl traveled a total distance of 4 light days and 8 days, or half the speed of light. He saw the Earth and space stations rotating at half normal speed. Due to that slowing, Carl only saw the Earth rotate 4 times in 8 days. The trip started when Carl saw 4 days on the apparent day clock and then saw 4 more during the travel. He should therefore see 8 on the apparent day clock. Since he is now 5 light days from Earth, he should see 5 fewer days on the apparent day clock than what's on the actual clock. Carl is going to travel back toward Earth at half the speed of light. Let's see if the numbers will still work out going the other way. Relative to Carl, he is stationary and the Earth and space stations are approaching him. The Earth and space stations are rotating faster than Carl's station. The special theory of relativity does not allow clocks to run faster due to their motion. Each time Carl passes a station, he will be 1 light day closer to Earth and will therefore have gained 1 day. Since he will pass 4 stations, he will gain 4 days, precisely what he lost on the outbound part of the journey. Perhaps time dilation does not really occur. If time dilation occurs when there is relative motion between 2 inertial reference frames, try considering the inertial reference frames of every object in the universe and then try to figure out how quickly or slowly our clocks on Earth should run. As we approach the 1 light day starting point, it's clear that when we arrive, all the apparent errors between the clocks will be erased. We will be 1 light day from Earth, all clocks will be running at the same rate, and no one is younger or older as a result of the trip. Thanks for watching.